let's now implement the method reverseOf. Again, given an integer array, and over here we don't assume the array is not empty. So that means the array can be empty. And also you're forbidden to use any library classes like arrays.sort. Again, we want you to use the for loop and use if statements if necessary and use loop counters to program the logic. It's much more important than just making use of the library. Okay, so now let's have a look at one example here and get an idea. First, look at that. The input is simply an array, and the output over here, the return value is another array. Okay, if you look at the utilities tester, you will see that the size of the output array, the size of the return array will be exactly the same as the size of the input array. They should match. That means in your method over here, you're going to just create another array whose size should be ia.length. Okay, now let's have a look at one example over here. So now you can see that, let's say we have integer array ia is of this array of size 6. Got indices from 0 to 5, and ia.length will be just equal to 6. Okay, so now let's walk through the steps of doing this. I will show you two possible solutions. One solution will be using 2 loop counters. The other solution will be using 1 loop counter. I'll show you the first one with with 2 loop counter. That's a little bit more straightforward, and I will show you how you can simplify that by using just 1 loop counter. Okay, let's see both, but both are equivalents. Okay, so now reverseOf. Let's have a look at that. So now if I give you this as the input over here, let's say this is the input, okay, that's the input. And then somehow this is the return value for your reverseOf method, okay. The return value is going to point to another array, and this array is going to be of size exactly the same as ia.length, which will be size 6. So we also got 1, 2, 3, 4, 5. So we got 0, 1, 2, 3, 4, and 5. So we got 6 indices over here from 0 to 5. Initially, when we first create the array, as we said before, all the slots will be just storing default values for the integer 0. But we'll eventually fill them in with the appropriate values. Let's think about how we're going to do that. So the way we're going to do that is, you can think about reverse simply means they should read forward and backwards the same. So which means when you talk about IA, if you try to read it forwards in this way, it's going to be 3, 6, 9, 12, 15, and 18. And now it should read the same as if you try to read from the output array over here backwards. So now the value for the output array, if you read it backwards, should be 3, 6, 9, 12, 15, and 18. That's what we should have. So we know the exact values, the contents for the array, so we can fill them in accordingly. Okay, so this is what I would do. In the first solution, I will show you two loop counters. Okay, so I will say counter number 1. Let's say loop counter. I'm gonna have 1 for loop only, and then I would say let's maintain 2 loop counters. The first loop counter is going to be called I. Initially, just 0. Okay, and then another loop counter is going to point to basically ia.length minus 1, the last index. Okay, so and then let's say j is assigned to ia.length minus 1. Okay, let's say we have that. And now this is how I'm going to do it. So now, first of all, I'm going to create a new array. Okay, so now you can simply say integer array. Okay, declare an array, and then you can call that reverse. And then what about I just type in the Java first of all. Okay, for this part I can just type. Okay, so now let me just do that quickly. So now over here I can just replace this part over here. I would say integer array, and then reverse is assigned to a new array also of type integer. And now what should be the size? It should be the same as the input array ia.length. And then I'll do something over here eventually, and then eventually I'll just return reverse. So now what's to be done will be this part over here. Okay, so now what should be done in this part? Okay, basically you can think about this is the reverse that I just created. Okay, so now what should I do? And I'm gonna have 2 loop counters over here, I and j. So I'm gonna have something like this. Let's say I simply define integer I is assigned to 0 for reading the input array forwards. And also I got integer j is assigned to ia.length minus 1. And over here you can also say reverse.length minus 1 because they are equal size, so it doesn't matter. Okay, for reading the return array backwards. Okay, actually you can say writing as well. Okay, so that'll be more that'll be closer to what we're gonna do. Okay, how do we make use of these arrays? So what I would do is, first of all, I would say for integer, actually we already got the 2 loop counters, so I'm gonna leave the loop counter initialization part empty, and then just state a state condition. I is strictly less than ia.length. Okay, that's how we do the loop usually. And then I'm gonna read it from 0 until ia.length minus 1. I plus plus. Okay, what I can do is I'm gonna do I plus plus and also j minus minus at the end. Okay, I will show you how this is gonna work. Okay, let's see that exactly. So now you can see that over here. So now initially, let's say in the first iteration, this is what we will do. For the first iteration, let's use green. In the first iteration, IA at position 0, which is IA at position I is now 0. So it's going to be at this position over here, right? And then reverse at position, so this is reverse. Reverse at position ia.length minus 1, which is 5, is going to be about this location over here. So we're going to assign 3 into this slot over here. Okay, so what we'll do over here is, so now let's say I and j, let's keep track of them. I initially is going to be 0, j is going to be ia.length minus 1 will be 5. And then, so what do? We do the following. We say reverse at position j is assigned to ai at position 0. Okay, actually not 0. That should be just I. Okay, this is j, this is I. Okay, in that case, it will be reverse at position 5, which is over here, is assigned to ai at position 0. That means we're going to assign 3 into here. Okay, that's what we will do. And then what we will do is we're going to go forward. So for the input array, we're going to go one step further. So now we're going to say I is going to be incremented to I is assigned to 1. It's incremented. So now it's pointing to this particular location over here. Let's say over here. It's now pointing to this location here. Similarly, we'll also do the following. Let's say for the j, we'll also increment it. You will decrement it actually because we are going backwards rather than forwards. So now that means j is now will be decremented to j is assigned to simply just 4 because it used to be 5. It's now 4. Okay, so now that means it's pointing to this location over here, right? So now after I plus plus and also j minus minus. So what we have right now is I will be 1 and j will be 4. Okay, and then we got another one. We say reverse at position j, the same as before, is assigned to ai at position I. So now j will be 4 over here, and I will be over here. So that means we're going to assign 6 into here, right? You can kind of see what we're doing here, right? So eventually, what we will do is we'll have also 9, and also 12, and also 15, and also 18. Okay, because the 2 arrays are of the same size, so the number of elements you have to iterate through, either backwards or forwards, will be exactly the same. So, okay, that's how we're going to do it. Okay, hopefully you can see the idea. Okay, let me just finish something over here, which will help us do the second version of the solution. Okay, and also you can see that I is going to be 2 over here in the third iteration, and j will be 3, and then 3, and then 2, and then, so let me just try to make some space for us so we can trace the whole iteration over there. Okay, let's do that. Okay, so we also got 4, and the last iteration will be 5. Okay. Okay, let me also try to make more space for us. Okay, that will do. 4 and 1, and then 5 and 0. Okay, you should really see the correspondence over here. The second solution that we're going to make will actually be based on the inside of the relationship between I and j over here. So we can reduce 2 counters into just 1 counter, but you can save that inside for the second version, which we'll talk about in just a moment. Let's finish the first version first. So what we'll do over here is, over here the body is very easy. We'll simply say reverse, which is the return array at position j, is simply assigned to IA at position I. And that's it. Okay, that's it. That's the first version. And now we can just execute a utilities tester and make sure it works. Okay, you will see that the reverse of is over here. Okay, so we got IA 1, 2, 3, 4, 5. Okay, IA 1, 2, 3, 4, 5. You can see that 1, 2, 3, 4, 5. So we're trying to reverse these 5 arrays. Over here, you will see that over here, reverse of, you can see for empty array it works. Empty array, let's see how the empty array will work. Think about it this way. If IA is an empty array over here, okay? If IA is empty, that means this line over here is going to create an array of size IA the length, which is 0, which will create an empty array. But now, that means we'll never go into the loop for any assignments over here, because for empty array, no index will be valid. So now in this case, in line number 116 over here, so now when we say I is less than IA the length, think about how this is going to fail for the first time. I is initially 0 over here, and what's IA the length? IA the length would be 0. So 0 less than 0 will be false, which means we don't even enter the loop for the very first time. So we simply just bypass this body of the loop over here and just return reverse, which is empty array. So empty array will just work. Okay, and also for other non-empty case, it also work. So you can see 75, the reverse is itself. 76, also itself. Now 5, 10, 15, 20, 25. We got 25, 20, 15, 10, and 5. Okay, so it really works. But now again, you can see that the programming itself is a faithful translation of what we think conceptually. So you really have to get the math correct about the how the tube loop counter work together before you can go for the next one. Okay, so this is the first version of the method. I would like to show you a second version. This version, I would say the first version would be more intuitive, even though we are using two loop counters. It's not that inefficient, so I think it's absolutely fine. But I want to show you a different version where we only use 1 loop counter based on how we observe the relationship between I and j over here. Let's see. So now what I will do is I'll comment this out, okay, and then I will just do another version here for you. But the first step will just be the same. Let's say integer. Okay, I'll say version 1 using using 2 loop counters. So what I will show you right now is version 2 using 1 loop counter, and then integer array. Let's say reverse is assigned to new integer array IA.length. This step is the same between the 2 versions. But now I only want to get 1 loop counter only. So now in this case, I can just put it here. Okay, integer I is assigned to 0, I less than IA.length, and I plus plus. Okay, and then now I will do something over here. I'll do that in just one moment. Okay. Basically, we want to somehow observe. You can see that, let's say the green one is an I value. Okay, 0, 1, 2, 3, 4, and 5. So we got 6 values because the array is of size 6. Okay, the number of values over here correspond to IA the length. On the other hand, we also get another column over here for j. Over here we got exactly 5, 4, 3, 2, 1, and 0. To be more precise to you, so somehow you can see in the first iteration, I being 0 corresponds to j being equal to 5. And in the second iteration, I being 1 corresponds to j being 4. And 2 corresponds to 3. 3 corresponds to 2. 4 corresponds to 1. And 5 corresponds to 0. Now the question is, do we really have to store the two values at the same time? Or it is possible to say, given the value of I, we know how to derive j automatically. Okay, that's the question, if we know what a pattern is. So is there a way to map this pattern over here? Okay, let's think about how we can do it. And now a hint for you, somehow you can see that geometrically speaking, you can see that 0 being the first index over here corresponds to 5 being the last index. And then 1 being the second index over here corresponds to 4 being the second last. And third corresponds to the third last. And then fourth corresponds to the fourth last, and etc. Right? So now, how can we go from first to last, and second to second last, and third to third last? So that's the question, right? So now, how do we do that? So now let's have a look at the relationship between I and j. Especially, I want you to look at, because I know the answer already, let me just give you a little bit hints. Okay, so what about this? What will be the value for I plus j? Let's make a column over here. Okay, we already got one column for I, one column for j. Now I want you to make another column. What's I plus j? I plus j for the first iteration, 0 plus 5, 5. And for the second iteration, 1 plus 4, also 5. Third iteration, 2 plus 3, also 5. 3 plus 2, 5. 4 plus 1, 5. And 5 plus 0, also 5. It seems like I plus j is always a constant. So that means I will just be, or j will just be 5 minus I. Okay? But what's really 5? 5 cannot be just a magic number, can it? So now, I want you to think about how can we derive this I, 5 over here. You can now think about somehow 0 to 5. You got 1, 2, 3, 4. From 0 to 5, you got 1, 2, 3, 4, 5 somehow, right? You have like a gap over here. But what's really the size of the gap? It has to do with IA the length, right? It depends on IA the length. In the case where IA the length is actually 6, that means this value will be just 5. Like a 6 minus 1. In the case of IA the length is equal to, for example, 10, then this value will be 10 minus 1, which will be 9, right? So which means I plus j will be 9. Okay, so now I plus j, 5 over here, is really equivalent to IA the length minus 1. Okay, so now if we know that, okay, given this, of course, this is based on some careful observation. So I'm just telling you the answer directly. You can try to observe on your own to see if you're really convinced. So now what we know is this pattern over here. I plus j is exactly equal to this number here, depending on the size of the array. Okay. So now let me just try to simplify that. So that's equivalent of saying j is exactly equal to IA the length, and then move I here to the right, minus I, minus 1. So this is the critical formula that we have observed from the first version of the solution. In the first solution, we got I and j, and we observe how I and j changes between iterations. We notice that I plus j equal to some constant that can be calculated using IA the length minus 1. So that's how we derive this formula here. So now, what we can do is we can only have I over here initially being 0, and then every time if we want to know what j is over here, we can just use this formula over here to calculate IA the length minus I plus minus 1. Okay, that's how the second version will work. Let's program that very quickly. So now you can simply just do the following. So now we used to have, you can think about, we used to have reverse j is assigned to IA at position I. We still have I, but we don't have j anymore. And j is exactly equal to, as we said, IA the length minus I minus 1. Okay, that's exactly how you will work. And then we don't need j plus plus anymore because there's no j, and we already got A++. So both versions are equivalent. So now we can just say return reverse. Okay, so now if we try to run the tester again, you will see exactly the same output as before because both versions actually worked. Okay, let's have a look at that. Okay, you can see that over here, reverseOf, you can see exactly the same output as before. So both versions work. So you should really try to study both to see which one makes more sense to you. I would say typically you might just start with version 1 with 2 loop counters, and then based on your observation to see how the 2 loop counters are related to each other, and then you can try to see if you can derive one from the other, so you don't have to store both at the same time.